So it's now 10:35. So we'll start the recording. So good morning, everyone. I am excited to have you here at the Life as an Engineer talk. Delighted about the conversations we're going to have today. And we have two amazing established engineers here who will be sharing their lives as an engineer with us. And when I say amazing, I mean it. So our guest speakers, Dr. Chu Chung Seong and IR Gan Zinang, is here to give us a peek into their lives as an engineer. First, we have Dr. Chu Chung Seong, the discipline leader of Civil Engineering Department at Swinburne Sarawak, who will be sharing his many years of experience as a geotechnical engineer and also inside a consulting firm with us. Followed by IR Gan Zinang, a project engineer who will be sharing his experience as a road and bridge specialist working on construction sites. So without further ado, let's give Dr. Chu our warmest welcome and thunderous applause as he shares his life as an accomplished engineer.
Yeah, thanks, thanks Lepang, for that very, very flattering introduction. And thanks to IEM-SSSS for the invitation. Personally, I'm very happy to see that our students are still engaged with IEM and engaged with the industry and with other students through IEM. And thanks for continuing this this effort. Also, now, if you don't mind, I would like to share my screen.
Oh, sure.
Yeah. Do activate that feature for me. Thanks.
Okay. Can you share now?
Yep. Let me try.
Okay.
Right. Yep. It should be coming up.
Yes. Yeah.
All right. Yeah. Thanks so much. Now, so my slides for today are mostly pictorial. But I do understand that our participants today are a mix. We have engineering undergraduates, or I should say, future engineers from various disciplines, and also at different levels in different levels of progress in their degrees. So I'll try to make this as open as I can. But first of all, let me talk about my favorite topic, myself. Yeah, so in case you didn't know, I'm Dr. Chu Chung Seong. Please just call me Chu. Don't call me Sir either. It makes me feel incredibly old. Right, so Chu is enough. I am from Kuching. I've been playing games since I was a kid. I still play whenever I can find the time. My latest, I've been playing mostly on Switch because I've always loved handheld gaming. I have many personal roles, and I have 4 siblings. My siblings are all in different industries. I have a brother who's a pilot and who works for an aviation company. I have another one who works in property management, strata management. Another one who works at to lead HR in a language services department organization. I also have another sibling who is a cancer researcher now pursuing a PhD. You can read the rest of it, and if you'd like to know a bit more, do scan the QR code. And you can connect with me via LinkedIn. My own background: I got my degree from Swinburne, so I'm your great grand senior. And I also received my PhD from Swinburne. My PhD was on microtunneling and trenchless technology. So I've also got under my belt about 10 years of experience in the various roles in geotechnical, various roles in the industry, whether as a resident engineer or as a consultancy. But I specialize mostly on geotechnical engineering. So I've been involved in the Kuching and Miri wastewater management systems, a bit of Pavement Highway, the coastal road network, slope protection, and even more specialized geotechnical engineering work like temporary works, deep excavations, and things like that. So, of course, in the uni, with my uni hat on, I teach soil mechanics. You may know it as geomechanics. I teach geotechnical engineering, and I tend to supervise FYRP students on industry-linked or industry-based projects and topics. Now, some of the areas of research that I pursue are, of course, geotechnical engineering, tunneling, and I try to do more of a high-end analysis, especially on not just finite element. Finite element is pretty common these days, but go into discrete element modeling. I also look into sustainable geomaterials for construction. There's more of upcycling waste into construction materials. And right now, my own pursuit is in machine learning and deep learning. Okay, so it's all AI. I go way back. I have links to IEM Sarawak as well. Right, and I also served on IEM-SSSS many years ago. Yeah, so just a bit more. All right, these are my personal music tastes. I don't think too many people listen to these bands these days, but I still love them. All right, these are the games that I've played, and I don't play many of them these days, but mostly, of course, are on Switch. So it's all the Nintendo titles. So I'm still waiting for that Metroid Prime trilogy. And Metroid Dread is awesome. And I enjoy comedies. I enjoy shows also. Yes, I'm one of those people who binged Squid Game. And I've got to say it's awesome, but nothing original. I've seen it before there was an anime series about along the same lines. I think it was called Kanji. I can't remember. Anyway, just to let you know, I'm a human. All right, yeah, so a bit of a background first about what civil engineering is, in case we have any participants here who are not familiar with civil engineering. So civil engineering is about the built environment. Once you walk out of your house, the fact that you're in a building, that is civil engineering. The moment if you walk out of your house, you see a road, that's civil engineering. You see a pipeline, that's civil engineering. You see a building, anything that is built around you, that's civil engineering. Even what is built under you is civil engineering. So all this engineering is only possible by understanding nature, by understanding the physics and the mechanisms that are happening around you. So in order to construct a building, to engineer a building, you have to know how concrete behaves. You have to understand how steel behaves and how the two work together to form reinforced concrete. If you want to know about your foundation, or you want to know about how tunnels behave, you have to understand soil. So what's the science of soil? How do soils behave? So that's engineering is about applying what you know about a material's fundamental behavior to understand the mechanisms and then finally engineer for it. Okay, consider it as part of your design. So just to highlight some of the Malaysian civil engineering achievements, of course, there's the KLCC Twin Towers, you've got KBMRT, Smart Tunnel, and of course, KLIA. I'll just touch on a little bit of the Sarawakian civil engineering achievements, such as the Pavement Highway, and of course, the Kuching wastewater management system. There are many others. All right, I'm just showing you what civil engineering in Malaysia looks like. Now, this is in general. Okay, this next few slides are not just talking about civil engineers. It talks about engineers in general. So engineers can have many different pathways. You can be a design engineer in a consulting firm. Nowadays, there are also project management consultants which hire a lot of engineers as well. You can also go into construction. And this third one is it's not, I shouldn't be saying industry, but rather more of a solution providers. So they can be suppliers, they can be software vendors, and they will also need engineers. You can also work in the government or implementation agencies, or you could do what I do, go into education. Okay, so as a consultant, what do you do? Well, consultants tend to be more on coming up with the design of civil engineering solutions. It's most it's on paper. is to do a lot of the pre-construction planning. So how big are your piles going to be? How thick is your road? Your road layer going to be? What is the requirement for the for the subgrade? What is the alignment of the road going to be, both vertically and horizontally? So all this is on paper. You have to be able to put it on paper before you can construct. There's an old saying when it comes to carpenters: you measure twice, you cut once. All right, so that's what consultants do that planning. Okay, the pre-construction works. Then once that is done, we go into construction. Okay, I'm talking about a conventional kind of engineering project delivery system. So when you go into construction, you are the contractor will usually have those drawings. Okay, and then they'll have to build based on those drawings. So if you think of it as Lego, you always have a manual, right? So you have the materials given to you. You've got all these bricks that are of different shapes, different colors, but you need a manual to put it together. So the consultant puts together the manual. The contractor puts together all of the resources and bundles them. You even package the bricks, your Lego bricks, into either different colors or different shapes, right? So that's what contractors do. But contractors more and more these days, they have to be sensitive to the environment. They have to be very sensitive to safety and quality of the construction. So just to share with you some of the sites here in Malaysia. So this picture on the bottom left, this was taken from the construction of the KVMRT project in KL, in Klang Valley. Also, this is right in the heart of Bukit Bintang, and you can see that this is a construction of a diaphragm wall that will be installed into the ground. This diaphragm wall will allow for the construction of a deep excavation, and this in the background is an existing building. You can see that the construction is practically right next to an existing building. So this is what I mean when contractors they need to be aware of the environment, all right, and the space that they're working with. So even though there are a lot of developments in rural areas, there is still some construction need in built-up areas, and they present their own challenges too, because of very dense, it's densely populated. So here's another example in the top right. This is the deep excavation for the construction of Plaza Merdeka. So the Plaza Merdeka shopping mall, before it was the building that you saw today, as you know, if you go to the mall, you will go, you want to park your car, you go down to the basement. So this is the construction of that basement, right? And you can see that it's a pretty deep basement, and it's right next to two heritage buildings. Here on the top left of the image, you will see the Textile Museum, okay? And at the back, that's the General Post Office. All of these are colonial buildings. They're not reinforced. So they're very sensitive to any kind of ground movement, and they can, with the slightest differential settlement, you'll see cracks, right? So these are the challenges, I would say, and the kind of sensitivity that construction projects, not just contractors, I would say, consultants too, right? They have to work together in order to come up with a solution that is sensitive to the society's needs. So the bottom right is just another picture. This is a picture from the KVMRT project. This is from the Cochrane Station. All right, Cochrane Station. Also, just to show you that this pit was about, if I remember correctly, it was 300 meters long, and I think it was 50 meters deep. Yeah, something like that. So it's well into the limestone cavities that KL is very well known for. Okay, so again, presents its own engineering challenges. In fact, you can see a little backhoe excavator right there. Okay, it's that small in this excavation. So in the industry, this is more of vendors and solution providers. So it could be to provide instruments, right, or materials such as what I'm showing here are geofabrics or geosynthetics, very, very heavily used in road construction, slope slope engineering. All right. And then these are some of the software that is used in civil engineering. Of course, Civil 3D, nothing new. By now, you would also be exposed to Revit. All right, for PIM. This rainbow image that you see here is Plexus. It's a finite element modeling suite for geotechnical engineering. So these also need engineers. Okay, this is another area which needs engineers. And of course, you have the government, implementation agencies. Their roles are usually to develop the public infrastructure and also to affect and implement codes and regulations. Some of the agencies, well-known ones are of course the Public Works Department like JKR. There's also DID, Department of Irrigation and Drainage. There are others such as JBAR as well. So. And the kind of standards and codes that they have is really their specifications and the kind of gazetted codes that they need to comply with. So some states in Malaysia have already gazetted the use of the Eurocode. You may have heard of it. Okay. And of course, education. So, civil engineers don't just, or engineers don't magically appear out of nowhere. All right. In order to have an engineer in a consultancy, in a contractor, at a government department, or working as a vendor, we have to train them. We have to groom them. So that's where education comes in. Right. So education is very, very much a part of engineering as well. So these are some images of course, labs. My apologies to all of the students here. You haven't seen a lab in a while, but I guarantee you this is what it looks like. Okay, and this is a view of our geotechnical engineering lab at Swinburne, and these are some site visits, to the Kuching Waste project. Okay, a few years ago. So just to share with you on why I became an engineer. This is an image of my uncle. He was a civil engineer. He's passed away, but he was a civil engineer. And I remember I did my O and A levels in Singapore. So I spent quite a number of years there, and he'd always pop by. He'd always pop by Singapore, and he's like, "Hey, just here, come, let's go have dinner." And every time he'd tell, we walk along Orchard Road. He'd always point to some of these buildings, say, "You know what they do there? You know what they do there? You look at this Ngee City or Takashimaya. Do you know the building can move? The building can bend one." I'm like, cannot be. I found it so hard to appreciate that, so hard to visualize it. So yeah, it's true. It bends ever so slightly. Okay, and you have to cater for that because as the building gets taller and taller, it's subjected to more and more of these wind loads. So he explained to me how he used to do it back in his uni days, and so in fact my family there are many civil engineers in my family. I'm a geotechnical engineer. My wife is a hydraulics engineer. I have a cousin who is a structural engineer, another who is a bridge engineer. My auntie is a construction manager, and of course there's my late uncle Kenneth Chu. So you could say it's in my blood. Right, but many of you will be thinking, that many of you may be thinking that you're an engineer because your parents told you to go into engineering, or maybe that because you were good in maths, and physics back in secondary school, therefore you should go with engineering. Let me tell you a little bit more, and hopefully by sharing my story, you'll understand why I chose engineering. All right. So, but now, even though I came from a long line of engineers, you can see that we're all in civil engineering, but in different fields of civil engineering. Okay, we wear different hats as well. Some of us are in construction, some working with contractors. Some of us work in the uni. Some of us work in consultancies. But why did I choose geotechnical engineering? Now, I understand some of us, many of the participants today, you're in your second year, maybe in your third year, so you may not know about geomechanics yet, okay, or geotechnical engineering. But let me just tell you, it's complicated, okay? And what you're learning, what you will learn, or what you have learned in undergrad is just the start. It's just the basics. In fact, geotechnical engineers have a big role to play. All right, and they have to consider information from many different, not just sub-disciplines, but many different perspectives. You're even looking at things like public policy, contract law, risk management, even mechanical engineering, construction. so the mechanics of it is only half. You can see that the science of it is only half of the role of a geotechnical engineer. The other half, all right, is very much to do with the environment. It's very much to do with people, with compliance with the law, okay, and with what is practical. And you can also see, that there are many different kinds of projects, okay, many different kinds of projects, and some are led by geotechnical engineers, all right, so projects such as slope stability, of course, whether it's cut slope or field slope, slope strengthening, all right, field slope instability, reservoirs, dams, retaining structures, basement excavations. These are usually led by geotechnical engineers. There are other projects where geotechnical engineers provide support. So they are led by structural engineers, they're led by civil engineers, but geotechnical engineers provide the support. So we have geotechnical engineers where we have many different roles to play in that sense. So, we work on many different types of projects, and every project is unique. It has its own needs and requirements. The client, or the client may develop it together with a consulting engineer. And, whether we are leading it or whether we are providing support, communication is so important. And I'll just give you an example, right, of this miscommunication or communication challenges. Geotechnical engineers work with structural engineers very frequently. Now, so all of your buildings are structures, okay, and they all sit on soil, so there is always that interface. But the problem is that for structural engineers, they carry out their analysis using soil springs, meaning they represent the soil as springs. But if you tell a geotechnical engineer, if you use the term soil springs with geotechnical engineers, they'll be really offended, because we know that soils are not springs. Okay, are soil springs? No, they are non-linear. Okay, they don't behave that way. But that's how structural engineers model the behavior of the structures. So knowing how to interface, knowing how to work together, all right, knowing how to work together is very important. So even though they need soil springs, find out from them what they're able to do so that it can best represent the needs of both the structural engineers and the geotechnical engineers. All right, there is always some win-win situation. There is always some win-win situation. So just to add on a little bit more about the challenges of being a geotechnical engineer. Now, this is a screenshot of the standard specifications for roadworks. I'm pretty sure our second speaker is extremely familiar with this, but I just wanted to highlight something. Now, if you look at the for slopes, okay, or for unreinforced slopes, the minimum factor of safety is a 1.3. Now, but for reinforced slopes, the minimum factor of safety is 1.5. So if you just look at slope engineering, all right, the factors of safety for a geotechnical engineer is 1.3 to 1.5. But we're dealing with we're dealing with natural material, we're dealing with soil. Soil has no QA/QC, not like concrete, not like steel. Okay. Now, but can anyone tell me what the factor of safety is for compression in concrete? Anyone? Just take a guess. You can switch on your mic. You can type your answers, your guesses in the chat box. Do you think it's higher or lower than 1.5? No, if you're too shy, okay, not to worry. Oh, yeah, we've got a response. Someone says 2.5. Okay. All right. Now, I'm not sure if you've gone through it yet. Okay, but I can tell you that the partial factor of safety, or the partial factor is 0.25. Okay, which means that it's a factor of safety of 4. The factor of safety of 4 for concrete, which is a QA/QC material. All right, it is it is something that you can control, is 4, versus a natural material like soil. You only have 1.3 to 1. In unreinforced slopes, okay, don't talk about reinforced. Reinforced, you have geogrids, you have geosynthetics. even then it's only 1.5. You're talking about very, very high risk for geotechnical engineers. So geotech engineering is not easy. Okay, it's not just that it's complicated. It's not just as abstract. It's not just that it's a mix of science with art. It's not just that it's very challenging, and not just that it's very high risk. Okay, it's very difficult. So why did I choose geotechnical engineering? Well, because I love a challenge, and I learned a lot, and because of the people that I met. And I think that it's important, and that's why I feel that I mean, when IEM-SSSS gave this opportunity to give this opportunity for me to talk, for me to present, I feel that this is a very important effort. This is a very important part of your growth, your realization into what you want to be. And that was why I became a geotechnical engineer. It's because of the people I met. They showed me the challenges, but they also showed me the way to overcome the challenges. They planted the seed of interest, and then they showed me how to work together and they guided me along the way. All right, so I have a lot of mentors. This is just one of them. He's my PhD supervisor, but he was really the first civil engineering lecturer I met. Right, and he's the reason that I decided to pursue my PhD when I was in the first year of my degree. So even though my uncle showed me all these buildings, all right, I because of my choice of my pursuit of geotechnical engineering, I ended up looking into the ground. So this photos from the Kuching wastewater management system project. I put up the Hock Seng Lee and the Judithara Jasa logo simply because they were my co-sponsors, or they for my PhD works. My PhD work was in this project. So yeah, I was very privileged. I did research for an actual ongoing construction project. That's that is really, really to me a real privilege. Okay, and it's on a kind of project, right? That a kind of construction method that was pioneering in Sarawak. At least there was no documentation of it. So just to show you some of the pictures from this project. So this is a photo of the microtunnel boring machine from Iseki that was used for this wastewater management system. Yeah, a picture of me when I had more hair on my chin. Okay, and yeah, one of the achievements from this project, there is a stretch of this sewer line that goes under the Sungai Sarawak. That runs along the Tanah Puteh Bridge, okay, where the Zakon Tollway used to be. So at the time, that was a record-breaking sewer system, and I remember when this punch-through happened, when the microtunnel boring machine broke through. It was at 11:15 p.m. So very happy to have been there to witness it. It's like witnessing the birth of a child. But this one is a mechanical steel baby. So I was not involved in the Klang Valley MRT, but I was very fortunate to have gone to the site. I not only went to the Cochrane station, I went down into the excavation and went into the tunnel. So I was one of the first passengers, first MRT passengers. But again, very fortunate to go right up to the tunnel boring machine to see how they construct the MRT tunnels. And so since then, I've been involved in many different types of projects, a mix of consultancy and a mix with academia as well. These are some pictures. In the top left, this is a photo of some of the slope rectification works that I'm involved in. Some pictures also from bore piling works. This is pretty interesting because if you see this bore piling, where they cut the pit to construct the bore pile, these are actually rocks, and you can see all of the dips, the joints, and the bedding planes. In the bottom right corner, this is a riverbank that had failed, and it was an erosion problem. So there's a weir there, and the river had had piped around, the river had piped around the weir. So, you know, we were, our role in that is more of a checking engineer, right? And of course, there's some pictures from, this is a picture from inside the tunnel of the Kuching wastewater management system. So in case you didn't know, right now, when you flush your toilet, or if you're in Kuching, now when you flush your toilet, right, it goes straight into these sewer lines, and then is pumped to a treatment plant, so a centralized treatment plant. And yeah, so I was one of the first to visit these tunnels, and at the time nobody flushed yet. Okay, so I'm not so sure if I'll go back in there so soon. And this is a picture from in the bottom left corner. This is a photo from piling barge of a project of a bridge for the foundation of a bridge and the coastal road network. Okay, so I'll show you some video of it, and this is a time-lapse video of this pile. This is a steel pipe pile. This length is about 30 meters, but the whole pile that was going to be installed is about 90 meters long. So these are steel pipe piles, 1.2 meters in diameter, which are 90 meters long. So again, not too many of these kind of projects around, and again, you know, very much a privilege to have been involved to see this very first pile installed for that project. And this is in the bottom right. You know, is an image of a test, or a pile load test for one of these piles. And again, this was, you know, once again, quite a privilege, because you may know about MLTs, maintain load tests. They're nothing new. Any kind of project which has uses deep foundations, which uses piles, you need to have an MLT done, you know, to check on the performance of the pile. But this was quite different. This one was an instrumented pile. It is a pile that you know, where we instrument it, we install strain gauges, load cells all along the pile, and then as it is being loaded, we monitor the performance. Now again, not that uncommon. Okay, instrumentation of board piles is not that uncommon, but this is a steel pipe pile, and to install the strain gauges on a steel pipe pile, not that easy. In Malaysia, there are less than 5 documented cases, okay, that I am aware of. There are not many. So again, quite a privilege to have been involved in one of this. All right, and yeah, some other pictures. Okay, but you know, as one thing about working in the industry is that things move very quickly, and construction projects move very fast. Everything is due yesterday. And so, you know, sometimes you will definitely come across some questions. You know, they'll pop up like why, and it's difficult to come up with an answer, especially even as a geotechnical engineer. One of the skills you have to have is to be able to read through scientific papers to look for answers, but sometimes you still can't find them. Okay, sometimes. So one thing that we observed, this is from my early RE days, is that the rocks under Kuching, okay, they're very fractured. Now this is a core box, all right, and you'll see, you know, that these are fresh, okay, as in they are, you know, we drill holes in the ground to collect samples of soil, and then under the soil is usually rocks. So when they usually come out as a cylindrical pieces of rocks. Now, if the rock is intact, is one piece, you know, great, okay. But most of the time, it is not. It is not intact, right? It's fractured. It's highly weathered, and it is not due to drilling. Okay, it's when we extract these rock cores, you drill for them, you core for them, and when you core, sometimes it can break the rocks. But those kind of breakages are usually running across the rock core. You can see all of these are not running across. These are not running across the rock cores. These are at angles. So these are properties, geological properties of the rocks. Now, what's the problem here? They're very fractured. So if they're very fractured, at least in the old days, the perception is that they're not strong. Okay, we use this term called RQD, rock quality designation. If the RQD is low because it's highly fractured, then it's an indication that the strength is low. But that's not true. This is a photo. This photo on the right is from the Kuching wastewater management job, from the first tunnel. They created that first tunnel with a TBM. Then they withdrew the TBM because they wanted to make some changes to the machine, but it left behind a tunnel. Now, if the rock was so weak, why is it that the tunnel can stand? Right? If the rock is so weak, if the rock is so fractured, and if it's fractured, it is so weak, why is it that it can stand? Why don't the rocks fall? Yes, there will be some small pieces falling, but generally you can see that the tunnel is intact. It is standing. So this was something that it was in the back of my mind. Even my mentor was also asking, it's strange, why, and it's nothing new. So that is also why I'm also a researcher, okay, in geotechnical engineering. It spurred a lot of research, and we ended up doing things like creating a transparent shear box. This is the direction test, not new. All right, it's a very, very common soil test, but we fabricated a transparent one so that we can take videos and take photos of the soil particles inside the shear box as the test is ongoing. Usually this shear box is made of brass, so you can't see the soil particles inside, but you get some results for sure, but you can't see what's happening inside. So we went to that level. We went down to this level of looking at the particles, okay, and in the hopes of trying to explain this, okay, explain what is happening here. So this is an accomplishment of ours. We were very the work was so fundamental in explaining what we had seen with with the fractured rocks, with the tunnel, that we managed to get it published in good journals, okay, and in good conferences, Q1, Q2 kind of journals. All right, so this is one of the satisfaction that I feel from this work, because you never think that the international community will look at Kuching, okay, but these are problems in Kuching that can with solutions coming from Kuching people, from us in Swinburne, Sarawak, that we're proud to share. And I think it makes Kuching a slightly bigger red dot. So these are some of the contributions. And just to show you the next level of work that we went to after this is discrete element modeling. You go into modeling the particles themselves. You don't model you don't model using springs, using elements, all right, or beams. You model the particles themselves, right? So from here you can see how the particles move, how they slide over one another, how they roll over one another, how they dilate, they compress. So again, we managed to present some of this. So just to share a few more photos of my career. This is the top left here is an image from a beard growing competition. No, it's not. All right, this is a picture from a seminar that I attended in Singapore together with some of you may recognize her. That's Dr. Elizabeth, who teaches road engineering. So this is with Prof. Chu Tian of NTU, and this is Professor David Moore-Wood from I think University of Dundee. He is one of those. He is he's like one of those rock gods in soil mechanics, and his textbook was my Bible during my PhD days. And so this is a training session that was conducted by this gentleman in the middle here, Prof. Harry Tan from NUS. Again, he brought Plexus into the Southeast Asian region, and he continued to champion the use of Plexus for many different geotechnical jobs. He's now retired, but I've run into him many times over the years. This image is from my first conference presentation here in Kuching back during my PhD days. So again, sharing the same image of the core box, you can see the same. The motivation came from all the way back then. And this is a photo with Professor Lee Min Lee. When I met him, he was at the University Tunku Abdul Rahman, and that he had worked on this area called biosource, the use of microbes or biotechnology to turn sand into sandstone. All right, you just imagine a process that takes hundreds of thousands of years, and he's using biotechnology to accelerate that process. Now it's not new, but at the time it was quite a new technology. And he's from Kuching. Okay, he's from Kuching. So a lot of Sarawakians making a splash. And this is more images. This is from my first international conference in Kyoto. And I got to meet, this is Prof. Antonio Jens. He's, again, one of those gods in finite element modeling. And when I got to meet him, I ran into this problem in my PhD, which was I was not sure whether my modeling, the numerical modeling that I did of the tunnels was right. And so I ran my idea past him. And he said, sounds okay, it sounds good. And I said, but it's deviating by about 20%. He said, that's perfect. If you tell me it's 100%, it's BS. There's no such thing. All models are wrong, but some are useful. You will not be able to capture anything, everything in modeling. So if it deviates by 20%, just postulate why there's that gap in 20%, and that deviation is where more research comes up. And that was so wise. It was so impactful to me. And him telling me that I was on the right track, it's like, being touched by the hand of God. It's like being blessed, okay, and telling you, don't worry, you're on the right track. And of course, being in Kyoto, we're going to see the sites. This is a photo of myself and my wife. She's also an engineer. And this bottom right photo. Now, this is a photo with my mentor, my PhD supervisor, Dr. Dominic Ong. And in the middle, this is a Prof. Marco Bala. When I presented our work, he was Prof. Marco Bala. I had read his work before presenting at the conference. He was somebody I look up to. I base a lot of my work on what he had done. But during the Q&A, wow, he was screwing me left, right, and center. He was saying, no, this is not right. And it was nervous. It was nerve-wracking at the time. But I realized he was interested, he was interested to find out more. So after the conference, I spoke to him. After my presentation, I spoke to him. I presented our problem. And he started to understand that, what are the challenges. And now he's a co-author, all right? We're co-authoring a book together with him. So, again, more pictures of many of the people that I've met. This is Prof. Zhu Jian again. Now this guy, as a geotechnical engineer, if you do not know who this guy is, all right, you really, really need to look, to do, I would, let me just mention that this is Prof. Harry Poulos. Prof. Harry Poulos is one of the grandfathers of deep foundations, okay? He has written so many textbooks. He was my PhD supervisor's examiner. I got to meet him in KL, right? Prof. Harry Poulos, he worked on mega projects like the Burj Khalifa. He designed the deep foundation systems for those kind of buildings, all right? And he's based out of Sydney. It's, so you can see now that I've met a lot of people, and it's what drove me, it's what made me realize that I was on the right track, why I know that I made the right decision. My career has taken me to, a lot of places in Asia and Australia as well. So we presented our work. My great satisfactions are, of course, knowing, of course, my other hat is as an educator. One of my great satisfactions is seeing my students graduate and watching them grow. Hopefully, when this COVID-19 thing is over, we can have actual graduation ceremonies again. Personally, I miss them as well. But knowing that they're doing much better than I am, knowing that they are at very famous and working in multinational companies, or even contributing back to Sarawak, contributing back to the local industry, that gives me so much satisfaction. All right, so let me just recap. Okay, I'll just I'm about to finish off my presentation. It's about the people. All right, it's really about that. The people that you meet. It's about mentors. It's about your peers. It's about talking and finding out why people do what they do. How do they do what they do? What is their thinking? you're not always going to get the answer that you want, the first, from the first person that you meet. But talk to more people. Some may not even give you the time of day. That's fine. All right. It doesn't stop you from talking to another person. It doesn't stop. You should find someone who cares. I think as a future engineer, one of the first things that you need to do is to find a mentor. You need to find somebody who will be able to guide you professionally and personally. All right. So this brings me to my, some words of advice. So meet people. All right. Talk to friends, uncles, aunties, teachers, lecturers, friends. Yeah, I mean your peers. Anybody. Even myself or Engineer Gunn, Engineer Henry today. Speak to them. Engineering is not only about crunching the numbers, but it's really about learning from those who came before you, so that you find that passion to sustain you, not just you don't just get the degree for getting for the sake of getting the degree. You get it so that you can use it. You get it so that you can signal to people of what that degree means. Okay, you talk to people to show people that you can be reliable, to ask for opportunities to demonstrate that you are a person, you are a personable engineer, you are a professional. So find a mentor, someone you can aspire to be, someone who can guide you through your personal and professional life. All right, and it's really because of this that I made the I made the decision to pursue a PhD back in year one. I knew what I wanted. I knew my end game. All right, and I'm always thinking 5 years ahead. Of course, work hard and play hard. Now, during your semester break, go look for an uncle and auntie. Just join them in their company, even if it's just for 1 week. Just sit in, look, see what's happening. If you have the opportunity to go to a site, go ahead. But of course, make sure you have PPE. Don't go onto the site unless you have a green card. Okay, but you can always look from outside, or you can smell from outside also. Learn a new skill. All right, pick up something. Now, information is so democratized. You can learn about machine learning. You can learn about graphic design. You can learn about digital marketing. Make the use of your time. All right, some of these skills will help bolster your skill set to be a more complete engineer. Right? And challenge yourself. There's nothing wrong with going to something difficult. Like I said, geotechnical engineering, it sounds like everything is against you. Okay, but there's nothing wrong. If it's difficult, nobody will do it. That also means there's a demand, right? So difficult takes a day, but impossible takes a week. So if you give it enough time, if you work with enough people, you'll slowly find that it's not as difficult as it seems. And now as a student, don't worry about making mistakes. All right, learn to fail successfully. Make mistakes while you still can, and learn from them. All right, don't be scared of asking questions. There's no such thing as a dumb question when you are in your undergrad. In fact, even when you graduate, there is when you're first starting out, there's no such thing as a stupid question. Okay, and so take it as part of learning. It is very networking, socializing is very important in your professional development. And yeah, that's all I've got to share. All right. It's pretty challenging to squeeze 10 years into 40 minutes, but I hope that I've done enough to at least give you a peek into why I decided to become an engineer. And I hope that this brings you some motivation. Okay, it's a tough part of the semester, so hang in there. Okay, and after that, you can always start to pursue again your interests, your passions for engineering. And so thank you very much. Thanks to IEM-SSSS. And shall we do the Q&A now, or leave it to after Engineer Henry's talk?
We'll leave it after IR Gun.
Okay, sure. All right. Thanks very much.
Thank you, Dr. Chiu, for the very inspiring and knowledgeable sharing. It was such an eye-opener for many of us, including myself, who will be joining the field in the future. So once more, thank you, Dr. Chiu. Applause for his wonderful talk. And let's now invite Ayargan to share his life as an engineer working on site.
Okay, good morning. First of all, I would like to thank IEM for inviting me to this talk. And what I'm going to share today is slightly different from Dr. Chu because it's more about, site views. And Dr. Chu talked about a lot of site as well, his site experience. But my part it will be more towards contractors, okay, as a contractors, as a civil contractors, and how to become a successful engineers, and basically the scope when you actually graduated and having your very first career. Okay, and allow me to share my slide. Okay. Are you looking at my slide?
Yes, we can see it.
Okay. Life as an engineer, as is what the topic for today. And my name is Mr. Gan Zineng. So basically, a little bit about myself. And I graduated from Curtin University, and I believe most of you would know that. It's in Miri campus, and fortunately, I graduated in the year of 2009. And I think one of the famous professor, Prof. Lau, is with Swinburne right now. And during my time, unfortunately, I'm like what I mentioned just now. I'm from Kuching. Swinburne have yet to have the civil engineering, and I wasn't able to join during my my bachelor time. So fortunately, only Curtin have that. So I joined Curtin Miri, and I managed to have my bachelor at the year of 2009. And my current position is right now is a project director from a company called Musyati Sendirian Berhad. I'm not too sure whether how many people really know about this company. I think if you're in Kuching, I think one of the famous projects that we are handling right now would be the very famous the 4th, 6 mile and 7 miles in the interchange, and also one of the Musa road that we are actually constructing right now. So a little bit on my total years of experience. Currently, like 2009 up to now, I have about 12 years of experience. And okay, by the time a little bit of myself, by the time when I graduated, my very first career when I started my engineering career is with, is in Kuching. One of the project, if you people get to know, is at this Isthmus Bridge. It's a balanced cantilever. So that is, I started as just a site engineer, and it's a very challenging project, and it's a quite a big, huge bridges, and it involves a lot of geotechnical works, bore piling, span piling, and a lot of and it is very exciting and interesting during those. And after that, I went to Singapore. I joined a company, and during those time I was working as a marine engineer. So basically, what marine engineers do? So marine engineers, we construct and build wharves, jetties, bridges, anything related to waters that we have to build on top of it. So that is very challenging. So from there, I worked in Singapore for about 3.5 years, and from there I returned to Sarawak, whereby it's my lovely and hometown. And I joined Musyati, and up to today that I'm handling a few of the projects that we have right now, and the most high profile that we have right now would be the Pan Borneo Highway. So later I will share a little bit of what we have been going through on this Pan Borneo Highway project for the past 5 years. Okay, so okay. Like what I said today, I'm going to share with you, responsibility and the scope as an engineers in the construction fields. Okay, Okay, first of all, the most important, I would say that safety is always the main priority. When you go to site, your safety is always the very first thing to come in place. And like you need to have the green card, the CIDB cards, and make sure that the PPE is worn at all times. And we must have a little bit of safety awareness knowledge in order that before you go into a site. Okay, the next thing that I'm going to touch on, I mean, to be a successful engineers, I mean, basically on site and as a scope of an site engineers, okay, these are the main key element and main key point that you will need to learn. You know, I mean, basically in our, university time, what we are actually learning is more towards some fundamentals and design and so on and so forth. But when you come into contractor's side, okay, there are very few things that, you know, we need to make sure that it is managed and controlled well, you know, in order to have a successful projects. All right. The very first one, without that, you will not be able to do all your works, okay, on site. The very first one and the most important one that I would like to say is your planning. So before a project commences, okay, you have to plan. Every engineers have to plan. It can be a daily planning, it can be a monthly, it can be we plan things ahead of us. So we things like so a good planning is something very important, and it leads to a successful project. So we have to, in order to plan, we have to forecast a lot of our construction sequence and based on the durations and the resources that is allocated to us. You know, every company or every project, they will have different resources. So with the resources that you have and the duration given by the clients, so from there you have to plan everything inside there. So in order to have a good planning, you will need to have certain experience on all the construction sequence, you know. Okay, so the next one, budget. Being a contractor or any kind of field, I mean, except governments, okay, except governments are the main objective here as a contractor, as a consultant, I think, is to make profit, right? I mean, is to protect the company interest. So by to me, a project, if you manage to control your budget well, so you will be able to, make do a successful project as well, and also make a certain, good profits there. And the next one that I would like to talk about would be on the construction material. Majority of our construction budget came from our construction material. So you control the material, you will save a lot of times and money. So being as an engineers, okay, how do we actually control the material? First, procurement. We procure based on our theoretical calculation, the material, the numbers, the quantity needed that required for procurement, and the time that we need the material to come in order for us to perform the construction activities. And also, there are also a lot of materials that have to come from overseas, West Malaysia. So you will have to plan them. Then it goes back to planning here. So you have to plan them in order to procure them ahead of a certain time so that they will come on your expected time. So as an engineers, okay, material on site, what should they actually do? Okay, here I would say that controlling your material by minimizing your wastage. Okay, structures or whatever things require a material, a concrete, rebars, timbers or any kind of other material. I mean, we just all the material quantity, like what I said, it can be tabulated and calculated theoretically, but sometimes a certain percentage of wastage is unavoidable. Just make sure that, I mean, as an engineer on site, we don't exceed that permissible kind of wastage, all right? And okay, next, would like to, okay, it's about manpower and machinery. Okay, to perform a construction work, okay, manpower and machinery, they are essentials lah. Okay, manpower, how do we actually have them? So by doing that, it's about recruitment. You know, as a main contractors, you can have your own teams, or you can engage a subcon to perform that activities for you. So it very much depends on how you actually want to manage the project. All right. So, and then machinery as well. You can rent them, and you can actually buy them, and to have your own, and you control them yourself, and this is how you actually going to control and manage your cash flow. Okay, so the very last one, which I would like to emphasize here, would be something very important for, I mean, all the engineers. I believe now during your university's life, you have a lot of assignments that you actually work, you are given a certain duration to complete, to submit, and you have to work in a team, a member like 4 to 5, or even sometimes smaller or bigger. So when you start to do a project, it is also the same. Okay, you are given a certain time frame by your superior or by your by the clients, you know, to complete a certain activities. So in order to do that, you will need a very, very good teamwork. A teamwork from your superior, a collaboration, a cooperation from your superior and from your peers, from your subordinates, and from the consultant, the design engineers, the client. So working as a team, to me personally, it will be one of the most important aspect to be needed in order, you know, to have a successful outcome of the project. All right. So, last but not least, not about scope of a site engineer. So today I'm going to touch you more about performing as a site engineer, because all this while, for my 12 years of experience, I've never joined a consultant design firm. I've been always a contractor all the time. So I will share. I also started as a site engineer, and salary very much recently the very hot topic, quite not too far from there. And okay, so scope of site engineers. Okay, the very first thing that you know, we need to do is that we make sure that we deliver all the tasks that is given by our superiors, by your managers, by your construction managers, project managers. So whatever task is given to you, you just have to perform them, and perform them well, and reporting your problems. And okay, like what I always say, every construction site, every site have their own problems, have their own issue, own constraints. So it's just how we actually can overcome them and solve them. So this is a very important things that every engineers need to come by, whereby they will face all these challenges in their near future to overcome all the issues. Okay, and you will have to, I mean, discuss that. If you can't solve them, you will have to discuss that with your superiors, and that is one of the main scope of an engineers. And also, when you first started as a site engineers, the very simple routine thing that you need to do on a daily basis is inspections. Inspection can be on any structures. It can be also a geotechnical works, foundation works, piling works, structure works, pavement works, bridges, or any kind of work. So once you are allocated to that particular department to perform that scope, you know what I mean, you will have to work closely with the consultants, inspector of works, you know, to make sure that any structures or any works that you perform are as per and compliance to the standard and requirement. I mean, I'm not too sure whether you have touched on the standard requirements from about Malaysia. We call that SSRW, the standard specification of roadworks. Basically, that blue book, we call it a blue book. It actually have all the requirement and specifications. I mean, for all the specifications needed to be constructed, and then tolerance that is given to be constructed on site. So something very important that I would like to advise here is that, I mean, we have standard, we have all the books to comply, but site is something different. Not everything can come by the book. There are a lot of you will have to learn this. You will be able to learn them when you actually come into you start your career. If happen one day you are a site engineer, you will know them. I mean, a book will give you certain standard, will give you some design criteria, how you come up with the structures, the numbers of rebar, the concrete that is needed, or the structure capacity that we need. But somehow a lot of things that we learn are from assumptions, you know. Engineering talk a lot about assumptions. So on site, we are more towards a practicality. Okay, so this is something that most likely all of you will be able to, to experience by the time that you graduate. Okay. Next, I would like to talk about the challenges that we are facing during our time during these constructions periods. Okay. In constructions, I mean, in civil engineers, we work under the sun. We don't stay too much time in front of inside the office or inside the in front of the computers, unless you are like the managers or directors level, you know. Most of the time you will be working under the sun. Okay, working under the sun is something not easy. You will grow very black, and during my time I'm very black in actual fact. So okay, the challenges. Okay, we have exceptional incremental weather. Sometimes we don't expect so many rainfall, but it just happened. So this will cause the project to delay and increase your construction costs. By increasing your construction costs by means of your overheads, the salary, the machineries that we need to pay, and the second one would be on technical matters. Technical, so construction, I mean, engineers, we are here to solve technical matters. All right, engineers design all the, our design comes from technicals. So there are a lot of technical things on site. That's why engineers are required in this field, you know. And another challenge that we are also facing, that a lot of people are facing right now during this pandemic time, would be this shortage of raw material. Construction cannot perform without material. You know, basically, like, you know, if you are shortage of a certain, for instance, I'm saying like there's no concrete, there's no cement supply in the market. So how do we do a construction? There's no way. And recently, it also happened to us, and this is something that we have to really look into that, and then some preventive measure have to be taken here to counter all these kind of issue. And insufficient manpower. Basically, in Malaysia, all our manpower labor, direct labor are mostly foreign workers. Mostly, I mean, in Sarawak, mostly is from Indonesia. Some are from Bangla. We have even from Thailand, and now we have a lot of from China as well. You know, so but during the pandemic time, it's very difficult to travel. You know, so without manpower, sufficient manpower, we are also very difficult, very challenges to the contractors, you know, to perform all the required work. So, okay, and also machineries. Machineries are also is also very important here. I mean, machinery, we have most of the time, every contractors have limited resources. So you are given a limited resources, and how do you fully utilize them, and how do you make sure that they are working all the times? And these are also some challenges that we are actually facing as a contractors here. And another one would be recently we have this COVID-19 pandemic that we did not expect during, I mean, this will come by to us as a human being. So, and with this kind of thing, it will, you know, you will face a lot of challenge, how to actually improvise your works, your constructions, and to plan them, and, you know, to minimize, I mean, the impact that will generate to you or to the company or to the projects. Okay. And okay, I'm going to, I've been, like what I mentioned in my very first place, I've actually, my past history, I have actually come by, completed more than 10 and above project, but I'm not going to share too much on what I have completed previously, because it's very difficult for people, you know. I don't think most of them are on a rural area. Some of them are in Singapore, and I did a WAF in Johor as well. And we did a connectivity road. If you people happen to know where is Kapit, we built a road in year 2016, and to connect from Cebu town to Kapit. So that is a staggering of about 50 kilometers of road. So whereby we have 2 balanced cantilever bridge and a lot of small RC bridge. So that is also something very challenged, and whereby those are a very rural area. You might not have even electricity or water, or sometimes you don't even have a phone line. So I mean, to be as an engineer is quite a, I mean, especially as a site engineer, sometimes it's quite a tough life. Okay, so today basically I'm going to share you of this existing ongoing Pan Borneo Highway, in which we are expecting to complete by end of next year. So by end of next year, I believe is something, a very high project. I think it's one of the largest project that Sarawak is having right now. So by completing that, by end of next year, hopefully everyone will have a very good highway, the very first highway road in Sarawak to ply on from Telok Melano up to Miri. And later on, we will be able to go through from Limbang and Lawas that is coming on. Okay, about this Pan Borneo Highway project, it's on our package. They are actually, I mean, splitted into 11 packages, and our company Musyati Mudajaya JV Sdn Berhad, we were awarded one of them, which is WPC8, which is located. Some of you might not know where is Selangor. It's between Cebu to Bintulu. Okay, the scope of this highway is upgrading from 2-lane existing R3 road to a 4-lane R5 road. I'm not too sure whether you people understand what is R1 to R2, R3, R5. It's actually a JKR government standards on the types of road. R1 refers to highway standards. Okay, R5, I mean R5 is the highway standard. R1 is quite a rural area, and most of the road that we are applying on the rural are mostly R3. Okay, so we have one interchange that is designed by Jurutera Jasa. I mean, our consultant here is Jurutera Jasa here. So it's an interchange and it's near completion. I mean, if you people have the opportunity, you will be able to come, and then we will be glad for you to visit. And electrical works, we have a lot of utilities work. Utilities are very important in our construction of this highway. You have waters, you have telco, you have power, and so on and so forth. So utilities is something that, you know, we have to, in our case here, we have to relocate them in order to avoid from damaging them before we can actually construct these four-lane dual carriageway roads. So it also involves some traffic management on site, because we are working on the live traffic in which we have been receiving complaints all of the time. It's not easy. It's not easy to go through as an as an engineer. So, you know, the public somehow do not understand our constraint. If you happen to drive in Kuching, I think most of you are now in Kuching, the 6 mile or the 7 mile or the 10 miles, people are now, you know, having a very bad impression, saying that there have been, you know, traffic jams for hours on a daily basis. I know we are the construction is creating some difficulties to the public, but no choice. These are construction. I mean, without going through this kind of construction sequence, there's no way that we can complete the road and deliver the road to the government, because it's a requirement. The design requires us to remove all the existing pavement. So no choice, we will have to close a certain land in order to construct for your comfortable, I mean, in futures, for everyone comfort, that they will have a highway to drive on. So this is something that publics do not understand, and we are always getting a lot of complaints from the public. All right. Okay. On as a site engineers, what else that we need to look after? Environment. Environment is one of our key elements that we need to protect. And then now we are talking about sustainable development, all these kind of things. So environment, we have environment management plan that we need to engage an environment consultant. I believe some of the engineer could be an environment engineer as well. To come up with a management plan, you know, to make sure that everything, whatever we construct, is not polluting the environment, you know, and it is within the given standard and specifications. And we have erosion control. I think erosion control is more towards geotechnical part. You know, landslides, a lot of things that can happen. So make sure that all these slopes or all the geotechnical works, though they are protected well from erosion, because we are a country, a place with a lot of rainfall. So erosion is also something that we need to, to give a lot of attention here. And another one will be on the dust control. And now people are also talking about noise control. You know, in construction, if you have certain activities are very creating a very high noise pollution. So these are the things that as the contractors we need to have some awareness, and to make sure that we will be able to practice all these all these environment management plan here. Okay. Okay, a little bit on contractors' view. I mean, on this Pan Borneo project, some of the details that, I mean, later on I will show you some photos that I am to prepare. So I get my engineers to provide me some photos. So later I will show you what are the constructions that we are actually having on site here. So for this Pan Borneo project, okay, one of the main work here is to perform earthworks. Okay, earthworks are earthwork moving, cutting of slope, filling of earth, you know. So earthwork, when we do an earthwork, we involve a lot of geotechnical works. During those time, we actually have a lot of soft ground. If you people get to know Cebu, it's quite an area with a lot of soft ground. Okay, how you actually, come towards with this geoground. So you will need geotechnical engineers' advice and their expertise, you know, to come up what would be the most practical way to perform the geotechnicals work in order that, you know, to solve the geoground, the soft ground issues, and so on and so forth lah. And drainage work, we have a lot of drainage work, a lot of culverts. Like what I say, I mean, we have a lot of rainfall. So drainage work, you know, you have in our, syllabus, we talk about, water engineering. We have to design the Q factor, the discharge, all these kind of things. So this is where all the drainage work is needed and designed for, and all the culverts. Okay, and okay, pavement work. Pavement work would be all the premixing, the tar seal work that everyone is driving on. So pavement work, in order to have a very good, in Sarawak, I believe majority of our road here are flexible pavement. So with the bitumen, we call it a flexible pavement. We don't have much rigid pavement here, but in other countries, they do have rigid pavement. So flexible pavement is come by with, our stones and some bitumen premixing works. So these are the very important thing as an engineers that you will have to learn on site how to actually do a pavement. You know, what is the compaction requires and what is the thickness required, and then how do you make sure that you can perform and, you know, and pass the inspection with the consultant, you know, within the SSRW, within the specifications limits. Okay, that is basically engineer jobs here. Okay, and we have 14 numbers of bridges. Bridges is also something very interesting. Bridges are mostly structural works here. So I think bridges is a bit different with pavements and earthwork. So properly, not in our field here, in my site here, we actually have a lot of, we actually split them into bridge engineers and pavement engineers. You know, so actually, so bridge, they are only focusing on bridges. So pavement are only focusing on pavement, because to us, these two fields are slightly different. So, I mean, by the time that maybe you have the opportunity to to come by as engineers, then you will be able to understand what are them, you know. And the last or not least, the next one that is about utilities relocations work. Okay, utilities in our project, why this project requires such a long duration. I think in the very first 2 years, we are only relocating all the existing utilities. Okay, so that is the very important challenge, constraint that we have, okay, for these mega projects. Okay, next I'm going to show you some photos, okay, of what this Pan Borneo project that is ongoing on site. As you can see in this photo, is about earthwork moving, you know. Okay, these are some field embankment that we have on site, you know, and it is actually a field embankment, you know. Certain compaction is required in order for you to perform the subsequent layers of activities. And as you can see, there are a few slopes nearby. Okay, and there are some drainage, interceptor drain, burn drain, and the utilities, the power on the left-hand side were actually relocated further on top of the slope. So here is something very important, that the slope has to be protected well. The protection can be a lot of things. It can be some slope protection. It can be some just a simple turfing with grasses, and you have to be protected well to prevent some erosion. The erosion can be something very severe. There could be some failures. If there are failures, it can happen that the power line, the power pole will be collapsed. If you imagine, if the power line is collapsed, that will be a disaster. Okay, and these are some of the photos of some earthwork activities that is ongoing on this current, on site right now. Earthwork excavations, we excavate by using an excavator and deliver by using a lorries. And on the right hand side is a bulldozer that is doing some trimming works, and later on you will need a roller to do some compaction. And you can see on the right hand side there are some geotextile covered. The purpose of covering the geotextile here is to protect the slope from erosions. Okay. And this is also some photos of our excavator cutting on the slopes. And this is one about drainage work. This is a roadside drain, And okay, this is about a culvert work. Culvert, most of the time we require to have a very deep excavation. Okay, after you excavate, you have to perform the structure works for the culverts, and on the right hand side is the completion of the culvert. Upon completion of the culverts, then we will have to backfill back all the embankment to reinstate back the pavement works, so that all the passengers car can actually ply on. Okay, I think just now Dr. Chu did mention something about geogrid. So this is a geogrid installation on site. This geogrid is installed on a sub-base layer, and we also have geogrid installed on the subgrade layer. So this is a kind of geotechnical reinforcement to increase a certain tensile forces here, which is designed by the engineer to prevent the filling embankment from failing. So this is a geogrid installation that is happened to be performed on site just recently on our site here. And this is also one of the geotechnical works key element on our site. Like what I say, Cebu have a lot of this area. We have a lot of soft ground. As you can see, on the left hand side, we are actually removing a lot of USM. We call that unsuitable material, which is a very soft clay that could potentially, collapse or whatever if you do not perform this removal. So we remove them. So up to a certain depth, we perform a certain geotechnical SI to look into that, how deep the excavation required up until the layer, so that the removal is required. Okay, so that upon removal, then we will have to fill back with some granular material. In our case here, mostly are sand and some geotextile reinforcing geotextile, in order to prevent them from failing, further erosion. So these are one of the suitable material excavations that we are performing on site. Okay, another geotechnical works that I'm going to touch here would be on the slope protection. This is one slope protection that is currently performing at the site. So it is also designed by the designer engineers, the geotechnical engineers here. The purpose to have this slope protection, because the geotechnical engineers found out that after the slope cutting, the material that is on the earth is very weak. It doesn't pass a certain criteria, and it have a very high potential failure if you do not protect them. So from there, the engineers will decide, to perform some slope protection. So here we have soil nail, we have shotcretes, and we have horizontal drains, some weed hole, because some of the slope, there are waters inside there. So they require a certain horizontal drainage to get the water flowing. So these are some of the slopes protection that we are performing on site. All right. Okay, here we have pavement. This is one of the pavement works that is performing on site. This is our Selangor interchange. Okay, on the left-hand side, you will be able to see that is the RE wall, and on the middle one, that is actually a one-span bridge. And on the right-hand side, it is another retaining wall. So on the middle part, it is actually a pavement. A pavement whereby it is on a sub-base or rock-base layer, whereby you can see this rock on top of it, and the machine are actually doing the required compaction and the required trimming out to the required design level. You can see that rod are not flat. Rod are actually with a certain gradient. A certain gradient were designed for the purpose of super elevation, and for also another purpose is not for, it's also for the water to flow, not to have the water to be pond. So you can see that all the rod design in our case here, we actually come with a certain certain gradient. Okay. This would be okay upon completion of your of these rod-based constructions, and after inspection, make sure that it pass all the testings and all the dipping or so on and so forth. We will be allowed to go for next subsequent works in which it will be to prime coat. What is prime coat here? So prime coating here is actually a kind of bonding agent, bonding in between rod base, rod surfacing with the premix. Okay, is something very sticky here. You can see that it's actually in a black foam oil type. So it is sprayed onto the rod base. Okay, before you can proceed to your next subsequent works, in which is premixing works. So upon spraying of that prime coat, we can only perform these premix activities on site. You can see that these premix activities is performed by manpower and machinery. Bearing in mind, the premix is very hot. By the time it is reaching on site, it could be up to 150 or 160 degrees Celsius. As you can see some ashes flying, and it is something very hot. So you might be the next engineer supervising next to it, you know, and being as an engineer, you have to go through this kind of life, and it is quite challenging, and it is also very exciting, to manage. And being as an engineer, sometimes you go through this kind of life, what you can get, out other than your salary, and you will get something, we call that satisfactions. Satisfaction not only from contractor side, also from consultant side. Satisfaction is something you will be very proud of yourself, whereby when you design or you construct something and it happens that it is performed well, and the satisfaction is what you have, and you deserve for it. Okay. And okay, this is a bore power. Unfortunately, you can't see the bore power machine. The bore power machine is at the back here. It actually finished the bore power boring works, and now we are doing a concreting work. Concreting for bore power, in our case here, we call it a trimmy concreting. It's not a normal kind of concrete mix. We call it trimmy. Why it is called a trimmy mix? Trimmy mix, we design it, whereby trimmy concrete can be pour in a water condition, in a salt condition, because most of the time it's very difficult. Imagine that you have a borehole of maybe 40, 50 meters. Some can go even deeper. You know, Jordan, I think Dr. Chu is well aware of that. Some of them, can go up to 100 meters, 60, 70 meters, very, very deep. So some of them are wet hole whereby you will have waters inside the hole, and you will have to perform using a 3-me concrete mix here, and to concrete the pile. This is one of the foundation works that we are performing on site right now. Okay. This is one of the bridges work, the rebar construction for after completing of your bore pile foundation work. The next step that we need to do would be the installation of all the reinforcement bar. Okay, you can see all these reinforcement bar from the photos. It is very, very, the spacing are all very small. These are all, during your design stage, I think we designed it as an engineer, designed based on our structure design knowledge, our steel design knowledge, why we need so much rebar, what are the required spacing required based on our analysis. So I think this is where your engineering professionalism come in place, and so in constructions inside, the workers have to perform and install them based on our design. Okay, upon inspection, you can see there's two white hat. They are actually performing some inspection, measuring on site to make sure it is installed based on the requirement. Upon completion of all this installation, we will install all the formworks and do the next subsequent concreting work. On your left-hand side is a completed bridge. Okay, so we are doing a symmetrical bridge whereby this bridge is ongoing here. Okay, as you can see that the photo is also taken quite recently. It's only like last week. Okay, and next, upon completion of the pile caps works, we have the beam construction. This is a girder beam, which has also been designed for. This length of this girder beam, I would say that if I'm not mistaken, is like 35 meters in length. So girder beam, I'm not too sure during your syllabus, have you designed a pre-stressing work? Pre-stressing. If you have that, pre-stressing is like post-tensioning work and pre-tensioning work. In order to have such a long span of girder, if we are only designing structures and rebars, we won't be able for the girder to have such a long span. So they will require a tensioning system, a pre-stressing system that is installed inside the beam. And there is a very high stressing force to stress. In order, from the eye view, there is some hogging on the beam. In actual fact, you can't really see them, but the beam is actually hogged. Okay, they have some hogging effect onto the beam after you perform the stressing. So that's why the beam can have such a long span without any support in the middle. So these two photos here is showing you how on site we are actually using some machineries, crane to perform the lifting and the installation of the beams towards the structures. Okay, this is quite danger procedure, a very heavy lifting procedure, because the beam itself can be like 100 tons, 60 tons, 70 tons. So in our case, in the contractor case here, these are called heavy lifting. So every heavy lifting in our case, we are required to have a certain approval before you can really perform that. And every people that is on site, make sure that they are actually accredited for and they are licensed for to operate those machines and all the riggers and so on and so forth. So these are some of the challenges that you might face one day when you start to actually to start your career as an engineer. All right, and this will be upon completion, you will have this kind of, this is on top of a bridge. All right. Upon of the completion, after the beam launching, we will have a deck slab, we have the parapets, but we still have a footpath to complete here in this photo, but the premix is completed on top as a surfacing on top of the bridge. So this is very much the outcome of a bridge upon your completion. And I would say that that would be all for my talk today. And hopefully that is good enough to share with you all. And thank you once again. And I think next will be our question and answer session, right?
Yeah, before that, may I ask, is it okay? Is my voice okay?
Yes, we are listening.
Okay. Before that, I would like to invite Miss Chacha, the portfolio director, students affairs from IEM, that's our branch, to have a few words. So let's all welcome Miss Chacha.
I'll end my sharing first. Right.
Hello? Can anyone hear me?
Yes, we can hear you.
Yeah, and thank you I'm Jaja. I'm from IEM GNS PD for Student Affairs. And first of all, I would like thanks to Dr. Chu and IR Henry Gan to share us today's on the very interesting topic about the life as an engineer in two different views, as an consultancy life and also the construction life. And I unexpected that today I also have the queue to give a very short on my working experience to all of you without any preparation, without any slide, without any photos. I just come back from meeting and suddenly be queued in. Sorry if anything that like I'm made into the shop lah, because I think that later we still have the Q&A section for two speakers. Maybe let me briefly introduce myself first. I'm Jia, and I'm graduate from UNIMAS in degree and pursue my master degree also at UNIMAS, but in the area of concrete technology. It's more on the research background. And after graduations, I joined, maybe I adjust my camera, cannot see my face. Yeah. After I graduate from my master degree, actually I'm planned to become a lecturer at the first beginning, but the ends, I joined to become as an engineer in the consultants. And I had the opportunity to involve not only in the design, and I'm also like hanging hold the positions also deal with the site people. Means that I also deal with Harry Gunn before in the Pavement project, and I also involved in the design. So I can share my experience different between the consultancy and also the construction life. I'm not totally involved, but I have tried to like become the part-time RE, so-called the part-time RE few months at the site for the very small project. What I can be summarized is that consultant, you learn about all the technical, and contractor life learn about how to build up the things by what the engineers are prepared in the consultants. So easy to say that as a good engineers, you need to have that both experience in design and constructions so that you can produce a very good design and then it's practical and constructible at site. So you have not so much of the issue like example, I give an example, you provide the part amendments where the at site actually is from whatever the info you have enhanced in your design, you see is like, yeah, I need to do this platform level A, but you never drop by site to visit and you issue out the drawing to the contractor. When you go to site, actually is unconstructible. Then you have the few turns come back again the issue to revise the drawing. Maybe have the VO is called as a variation order where a lot of the thing can be actually solved out if you have the site experience and also the design experience together. So what I want to summarize is that I think a lot of students here, sorry, have the call. Yeah, so I want to summarize here. A lot of students, I think they are still in the dilemma condition that whether I want to, after I graduate from my degree, I want to join for consultants or joy for contractor life? What I want to advise?
Life, huh?
Yeah, what I want to advise, I think a lot of people here, they also approached to me before the swimmer students. One of is the first people who greet me. Until now, she's still not sure what is the way she can go, consultant life or contractor life. Because as a girl, especially as girl, if go consultant, maybe it's like 9 to 5 in the workings, in the office. But is it possible girl to join site? Yes, I see a lot of people, girl engineer at site, and they do very well also. For guys, they're thinking if I 9 to 5 in the office, is it like I just like doing the office work? But yes, you can do it better. Actually, no matter what, actually you are girl or guys, engineer is open to everyone. So hopefully for today's talk, from the experience sharing by Dr. Chu and also I Henry Gans, give you all the clear directions, and you have like can avoid like this dilemma condition to choose which path to go. And then today you make a decision, go for it, try for it, and do for it. That's all from my short speech today. Yeah,
Okay.
I think yeah.
It's a very good sharing. Sorry for the.
Thank you, Dr. Chu, to cue me in also.
Yeah.
And I Henry.
Too much lah. I was saying that the IEM-SSSS should invite you for a full session. But we take today as a sneak peek lah, huh? Then this one is akan datang, right?
Yeah, if suddenly the student text me, later I cue you in for soft speak for around 5 minutes. I have not prepared anything. And thank you again, Aya Henry, for your times, and Dr. Chu. Because I know both of you are very busy, and then you still like spend your valuable time to us, and then sharing your own experience to the student and let them have the direction to go forward in future.
No, thanks to IEM SSSS and IEM GNS. We're very happy. And I think both of us, all of us here, we recognize what you had just mentioned, that we were all students once before, and whether it's ourselves or whether it's our friends, our course-mates, we always have that crossroad. What should I do? Sometimes it's a good problem, so many opportunities. So which one do you want to take? I think your advice is good. Give it a try. That's what your internship is for. And with online now, a lot of online learning, to be very frank, you can go for your internship during a semester. That is my own take, and I think that you should. I personally know of students who have done it, so they do their studies and their internship at the same time. So I think that's an opportunity. You should give it a try. All right. I don't think anybody is going to screw you during your internship. You have all your students anyway. Nothing to be worried about. Okay, just take it as a learning opportunity, and try to find out whether you like what you see, you like what you smell, you like what you not taste. Don't go and taste the unsuitable soil material that I and Henry were talking about. All right, but do you like it or not? Do you like the feel of it outside of the drawings on your in AutoCAD? Do you like it outside of what you see, all these lines on paper? What is it like to be in the real world? All right, that's where real engineering happens. So thanks again for the opportunity.
Okay, so thank you for all of your for all your sharing. Thank you, IR Gan, Ms. Chacha, and also Dr. Chu for the lovely session. So for now, it will be the Q&A session. So participants, please type your questions in the meeting chat or unmute yourself for any inquiries.
One more thing that I would like to add on here. I mean, if happen that there is any, graduate engineers that would like to actually apply for a job, I mean, you are almost welcome to apply from us. We would like, I mean, like what I said, the demand is very high. I mean, as long as you will be able to work outstation, I mean, if you're lucky, you will be working at your hometown, but most of the time we are unable to do that as a contractors. So I mean, we would be glad that if you would be able to send in your applications, your resume, and you know. So we are looking forward to that. And then if you need to have our email address, I think I would like to share, or you can get it from Jaja. Right.
Yeah. You can share your all resume to me also. You want to apply consultancy or contractor, then you let me know. I will help you to distribute.
Yeah.
Okay, so personally for me, I would like to know, how did the pandemic really impacted all of your fields? Is it a good way or a bad way, or is it just as it is?
Henry, maybe you can say your material cost.
I mean, what is the question again?
Oh, how's the pandemic like? Is it impacted very deeply, or is it just as normal as the pandemic before?
The impact is huge. The impact, in actual fact, it impact all of us. Okay, first thing, the impact will be, it will be very difficult to travel. It will be very difficult for material to come by, and a lot of factory were closed down, and they reduce, or some even when they open up, they reduce their so-called the productions. So we have very limited resources available during those time. And at the same time is that workers, when a pandemic when there's a pandemic, the government, we were actually ordered to stop work for a period of time. I think everyone is aware of that. So a lot of workers, subcontractors, they could not survive. And the workers left them. And by the time that we are now reinstating back a lot of things, and to start on recruitments, and to reinstate back, it actually require a certain time to get back to a normal situations. So those are the things that we are facing right now. I mean, materials and manpower.
Okay, so there's another question. When we are working, I believe as an engineer, we might be given the task to supervise the construction site. What would you do when the workers were trying to cut corners and use slightly lower quality materials when you are on your break to cut costs?
Well, engineers have to stand firm. Okay, we have to stand very firm on our perspective, and we will have to reject them and make sure that it is complied to the requirements. I mean, we shouldn't allow any cut corners in our field. You know, that will give us a very bad reputations, and I mean, this is from my point of view.
I'll just chime in here and add on to what Engineer Henry has said. It is our duty as a professional engineer to put the society first. That's why in the designs that we prepare, right, you notice that the term factor of safety is very heavily used. And it's because our duty is to the rakyat, is to the society first. Having this kind of subpar worker like what Engineer Henry has said is automatically rejected. Compliance is a very important compliance with the drawings, especially if they're already taking into consideration if they've been designed for safety.
Yeah. Imagine if the structures or anything fell, I mean, and it involve life or what, and then you will feel very guilty for that.
Yeah, there are a lot of high-profile failures. If you want to find out, a very famous one was in Singapore, the Nicole Highway incident. You can read about that. Yeah, that was part geotech, part structural, and all temporary. Oh, this Chacha, maybe you want to chime in on this one. You have a way with dealing with consultants and contractors.
Sorry, I have another course. Actually, how to say for these ones, discussions.
I think it's very hard to argue with facts. In the first place, in the first place, whenever if you see something like this, make sure that there is evidence of it. Otherwise, it's just hearsay. You're just pointing fingers. And if there's any evidence, also, be careful. Try to talk to your superiors first. Let them know, and and don't go in on it alone. Because the thing is that there are, you're always working in a team. So in that way, you also know, you cover different perspectives, like why it is that what will happen, due to this non-compliance, what to do next. So you can't just say, you can't just accuse, and say, oh, this, you didn't do this. The next question is always, so what? So what are you going to do? So and also explain, all right, that, and don't threaten. Never ever threaten. Okay, it's not part of your professional conduct, and and you should never say, you don't do this. I tell you, issue NCR. Or then don't do that. All right, we try to escalate it slowly, and because sometimes and we try to point out, it could be the first time, and then we say that maybe this particular worker maybe blur, it could be other things like that. It could be a side matter. So just alert the construction team, and try to discuss it amicably lah. All right, and don't honestly, if you let emotions get in the way, those are the worst times to make any decisions.
Well, something to add on here. I believe engineers, as our professional, as a professional on site, we have the absolute rights to reject. So by rejecting them to tackle the issue, once upon our rejection, they will not get any paid. So there will be a concern that if they are not getting paid, they will make sure that they're rectified up to the satisfactions and up to the requirements. Only they are allowed to do a subsequent work. From there, they will only get paid. So this is one way to tackle the issues. We reject them, they are not getting paid. So they will be afraid to do those kind of things.
Yeah. Is that all that our participants have?
I have a question.
All right, love to respond. Okay, so now we'll move on to the token of appreciation. So we'll like to give Dr. Chu and Henry Gan a certificate as a token of appreciation.
Thank you.
So, Dr. Chu. Okay, so Dr. Chu, this is your certificate, and we will send you another email with this one.
Okay, thanks.
Okay, thank you. Let's move on to IR Henry.
Thank you.
Okay. So can we have a photo taking session with all of our participants? So don't be shy. Let's open our cams.
Like my daughter, in her class, she's in Hindi. So in her class, the cameras are always on,
Yeah.
and the microphones are always on. But in uni, all off. And I only see letters. I never. That's why earlier on, right, I didn't know who. I couldn't recognize Chan, and I couldn't recognize Natalie because I haven't seen them at all. Yeah.
Yeah.
Hey, Jaren. Hello. familiar face. Yeah.
So,
Yeah, Jared is one of
Hello.
our engineers and planning managers in our company.
Mm.
wow, hi,
Hi,
Hi.
Darren.
hi, Jared.
Yeah,
Next time should
maybe
be
you can
funny.
introduce yourself also to everyone here.
Okay. Hi. I'm Jaren. I'm basically IR Gun's colleague. We are working on this Pavement as well. Actually, more than that, we have airport project as well. I just came back from Sabah last week on KK Airport and Sanakan Airport. We're doing extension of parking apron and runway. Yeah. Besides that, we have the 4 interchange in Kuching, the 4th mile, 6 mile, 7 mile, and 10 mile. The hectic jam every day. The complaints you get every day, but as an engineer, we have to follow the sequence of work. We cannot just those politicians are complaining like, how can you just do this in 2 days, 3 days? I mean, we know lab testing, we need at least 24 hours to get one FDT test result. Yeah, so we cannot proceed much. Yeah, so I'm a planning engineer in Mushati. This is my company I'm working with. I've been doing planning for 6 years already. Yeah, I mean, construction field since 2013 until now. And I've worked with JASA as well before on this Murum project, the slot protection. Yeah, at that time I was working with Anson, one of our Swinburnian as well. Oh, by the way, I'm from Swinburne as well. I was from Swinburne. Yeah, graduated in 2011. But I did my training. I did my training in Melbourne, the Swinburne Houghton campus. Yeah, so yeah, basically that's about me.
Thank you for the sharing.
Welcome.
Yeah.
It's
Photo
lovely to know.
time.
Yeah. Okay, so let's take our photo.
Wait, this Fang Jie is still at the Civil Kopitiam.
Yeah. Okay.
Okay, ready? 1, 2, 3.
So,
Yeah, done already.
okay, done. Okay, thank you all for joining the talk. And before leaving the session, please fill in the feedback form by scanning the QR code.
Yeah. Mr. Chairman, we've still got one question from Ahmed.
Yeah. Okay, so I have a question. As an international student, what is my ways working in Malaysia? Which speaker would like to answer that?
I think you mean to apply to work in Malaysia, is that the question?
Yeah, as an
Okay,
international
I
student.
think Dr. Chu, I think both of us, we work overseas before. It's quite similar when we go overseas. I work in Singapore. We just need to apply their working permit as simple. I think to come to Malaysia, you also have the similarity and you just need to apply the work. The company have to apply for you. Okay, it's not that difficult. I mean, we have human resources that is actually working with the immigrations. They can do that. Yeah, we have a few colleagues that is also overseas. It's not that it can be done.
Yeah, that's right. Usually, I would say the larger companies, they will have they have HR who can get in touch with these agents as well to expedite it. Then they know how, they know the procedure, they know how to get the EP and all this. So you might want to write into Engineer Henry.
Why
See
not?
whether there are opportunities there.
We have
Right?
Philippines engineers, we work with them. It can be done. It can be done.
Mhm.
Yeah. And furthermore, I would advise it. You can actually apply for PR as well.
That's the good thing about the degree that you have, because it's accredited lah. So it's recognized. Across a few different countries. So whether it's Malaysia, UK, Australia, is a passport. So you're already here, all right? You can even register as a engineer here. This is a pretty recent thing for internationals to register. I believe it was only a few years ago, right, that internationals were allowed to register here. Register with the board, if I remember.
I think recently BM just had ASEAN Chartered Engineers that you
Yep.
can also apply for it.
Yep, that's right. So there's the APEC APEC registration as there's Asia Pacific one. There's also international PE lah. So there are definitely opportunities and for career growth as well.
Yeah, definitely there will be. So is there any other questions before we end the meeting? Okay, so once again, thanks for Dr. Chiu and IR Gan, and also Miss Chia Chia for the session. We really do learn a lot from here. Yeah, thank you.
Thank you.
Thank you.
Thank you. Bye, everyone.
Bye. Thanks everyone. Take care.